Okay, we are now on 4.4, which is the last section of our chapter, and this is called Introduction to Trig Equations. So it's just like solving regular equations. Some of the steps are going to be the same, except for at the end we're going to be doing the inverse functions. So starting off with this first one, 2 times the cos of theta minus 3 equals -1. So we can start by adding 3 to both sides. So we get 2 times the cos of theta is equal to 2. Divide both sides by 2. Cos theta equals 1. So now we think, well, sure, you can do inverse cos of 1. You can go theta is equal to the inverse cos of 1, right? What does this mean, cos of theta is equal to 1? That means that what is the theta? What's the angle so that we have an x value of 1 on our unit circle? So this is x here, so x will be 1 right over there. Here x is 0, here x is -1, here x is 0 again, here x is 1. So we'll say of our xy, this would be, the ordered pair would be 1, 0. That's that spot. So what is the answer? Theta would be equal to 0. And if we're talking about degrees, it would be 0 degrees. Now, our interval that we're allowed, the domain of theta in this question is between 0 and 540 degrees. So the period for cos repeats every 360 degrees or 2 pi radians. So our next one would be 360 degrees. And if we were to go again, we'd hit 720, but 720 degrees is too large, so we can't have that one. And if we went negative, we'd go to -360. So there's our answer, 0 degrees and 360 degrees. Let's take a look at the second one. First thing you'll notice is that we are talking radians in this question and not degrees. So when you look at the interval, if it's in radians, then we do our work in radians. Okay, so 4 secant of x plus 8 is equal to 0. So again, we want to get x by itself. So first we'll subtract 8 from both sides. So 4 times the secant of x is equal to -8. And now we'll divide both sides by 4. So secant of x is equal to -8 divided by 4, which is equal to -2. Now, if you recall, secant is the reciprocal of cos. So what I'm going to do is take the reciprocal of both sides. So now I'm going to say that the cos of x is equal to -1/2. Okay, so what does that look like in our unit circle here? When is the x value, because cos is x, not because this is an x here, we can have x or we can have a theta or whatever, but when is the x value equal to -1/2? So it would be there, so -1/2, and there. We're going to have two answers. So our reference angle here, another way of thinking about this is that our reference angle is going to be a +1/2. When is cos equal to a +1/2? And the answer is this pi over 3. Okay, so my reference angle is going to be equal to pi over 3, and so my answers for x will be, well, it's negative, x is negative in quadrants 2 and 3. Okay, so in quadrant number 2 we will get, so this one here, that would be 2 pi over 3, and in quadrant number 3 the answer would be 4 pi over 3. Right, because this was pi, this is 3 pi over 3, so that's 4 pi over 3. So those are my two answers here. I guess I could best write them like this: x equals 2 pi over 3, comma 4 pi over 3. Let's just check to see whether I'm within. Yeah, so it's a nice friendly one, isn't it? It's between 0 and 2 pi, so it's in the first positive rotation. Okay, looking at our next question here, we've got sine squared x and sine x and all this kind of stuff. So it looks like, oh, it's a little intimidating. It's pretty straightforward in my mind anyways to have secant x instead of like a or b or things like that. But some of you might want to replace this sine squared x with a variable squared. So if you want to do that, that's okay, but you just have to be very specific. And let's say let a, for example, I'll just choose a letter, equal to the sine of x. So then this becomes a squared minus a equals 0. Okay, and then we can factor this. A multiplied times a minus 1 equals 0. And now if we want to put it back into the sign here, I'll just use the word English word so. So as a result, or therefore, all kind of means the same thing. I'll go back and replace a with my sine x. So this is the sine of x multiplied by the sine of x minus 1 equals 0. Now you don't really have to do this. This substituting it in for a and then coming back again, totally optional. You could just go, so maybe just write this here. This is optional. If it helps you think clearly about the question, go ahead and go for it. But otherwise, you can go straight from this line to that line as your next step, perfectly fine. The only thing I'd like to point out is that if you're going to substitute a for sine x, you need to make this statement. Okay, so the whole thing is optional, but if you're going to do it, make sure you include that line. All right, so when is sine of x equal, like either of these two factors can be equal to 0. So the next step would be the sine of x equals 0, or the sine of x is going to be equal to 1. Let me just get a bit more room here. So on the unit circle, sine is the y value. So when is y equal to 0? It'd be down there, wouldn't it? And we are talking degrees, and we're talking between 0 and 180 degrees. So when is the y equal to 0? Well, that is not in our domain, is it? So this would be 270 degrees. Yeah, 206. Let me see. Y is equal. Here, let me just pause here. I was a bit confused there. When is y equal to 0? So this is my y value. Y is equal to 0 either here. Oh, let me get it. Come on. Either here or here. This would be x is equal to 0. So I don't want to think about that. So at this point, x is 1 and y is 0. Over here, x is negative 1 and y is 0. Okay, so just to, in my mind, just to say, yes, y is equal to 0 here and here. And it's y because we're talking sine. So my two answers in degrees here would be 0 degrees and 180 degrees. And those are both within this given domain of x. When is sine of x is equal to 1? So when is the y value equal to 1? So that would be up here. So that answer would be at 90 degrees. So I'll just put comma 90 degrees. So here are my three values of x that I can have. And I guess it's nice to put them in ascending order, but it's not really required. So no problem. Looking at letter D here, I got 10 squared minus 1 is equal to 0, and again we're talking about radians, and they're kind of mixing it up a little bit about between negative pi and positive pi, so we'll take a look at that as well. Now I guess the first thing to think about is this reminds me of, or this tells me it's a difference of squares. It's like when we have an x squared minus 1 is equal to x plus 1 times x minus 1. It's the same kind of, it's the same idea. So what does this look like when we factor it? We're going to have a tan theta plus 1 multiplied by a tan theta minus 1, is that's going to be equal to 0. So when will the first factor be equal to 0? When tan of theta is equal to negative 1. Or this could also happen, either this is true or that is true, tan of theta is equal to positive 1. Now, thinking about the way tan works a little bit, and I talked about this in the previous sheet up here. If you still have that, you can kind of remember how tan works. It's these pi over 4s, right? Because both the x and the y values are the same, root 2 over 2. So it's those pi over 4s you have to take a look at. So scrolling back down over here, tan of pi is going to be equal to negative 1 here and here, right? And tan of pi is going to be equal to positive 1 here and here. Okay, so let's look at our the domain of theta, what all the values that theta can be. And you'll notice it's negative pi and then up to positive pi. So for both of these, we have to think about, if we're starting from 0, we're allowed to go, and maybe I'll switch to green here, we're allowed to go positive for a half rotation up to positive pi, and we're allowed to go in the negative direction up to negative pi. So we'll hit each of these values once. So when we go in the positive direction, so my reference angle is pi over 4. We are in radians, pi over 4. This is 3 pi over 4. And going in the negative direction, when we hit this one will be negative pi over 4. These are my two solutions so far. Or so we're going to include all of these afterwards. Here, same idea. We have to include all the negative from 0 up to negative and positive. So that's my positive direction, and that's my negative direction. So this would be positive pi over 4. And this one will be negative 3 pi over 4. So at the end of the day here, I'll be nice and I'll state them in ascending order. So from the smallest, furthest to the left on the number line would be negative 3 pi over 4, and then negative pi over 4, and then pi over 4, and then positive 3 pi over 4. So there we get our answers. Okay. Looking at letter E, I got the need to go back to blue here, so we'll go back to blue. Looking at E, this 2 sine of x plus 1 and 2 sine of x minus root 3 equals 0. Kind of nice, isn't it? They've already factored it for us. So either this is going to be equal to 0, 2 sine of x plus 1 equals 0, equals 0, or 2 sine of x minus root 3 is equal to 0. So solving for the sine of x will be equal to, well, let me think here, if I subtract 1 from each side and then divide each side by 2, it's going to go like that. I'll carry over to the right hand side. Here the sine of x will be equal to, if I add root 3 to both sides and then I divide by 2. Okay, so when is the sine of x equal to negative a half? Okay, so sine is the y value. I can think here that the sine of my reference angle would be equal to a positive half, so that my positive half is over there. There, it's that pi over 6. And when is sine is negative? In quadrants 3 and 4. So the sine, so that it would be this quadrant over here and that quadrant over there. So I'll say x is going to be equal to 7 pi over 6 and 11 pi over 6. And that's all from this solution over here. Okay, looking at our second solution, when is sine of x equal to root 3 over 2? So root 3 over 2 is a much larger one that's up there, and that is our pi over 3. And sine is greater than 0 in quadrants, quadrants 1 and 2. And so my second one would be up here. And so it would be x can be equal to pi over 3. That's my first one. And my second one would be 2 pi over 3. So I would add all these together. X equals, oh boy, if I want to do it in order from smallest to largest, I'd start with my pi over 3. And then my 2 pi over 3. And then my 7 pi over 6. And my 11 pi over 6. So I got those 4 answers. And let's just do one more check just to make sure, is it inside this interval here? Yeah, we're okay. We didn't go smaller than 0. We did not go larger than 2 pi. All right, so let's take a look at our next page here. Now we got this, looks kind of like a quadratic term here, and we can, I think this would be a good one for us to use our let approach here, just to simplify it in our mind a little bit. I'm going to let a equal to the tan of x. So what this turns into is a squared minus a plus 6 is equal to 0. So if I factor that out, a minus 3, you know what, I don't think there's any way that this is going to factor out. And in fact, I think that this may have been a typo. So why don't we do something? Why don't we change this to a minus 6 and change this to a minus 6 over there, so that we can actually make a question out of this. So we can also say a plus 2 is equal to 0. And so we can have the tan of x minus 3 equals 0, or the tan of x plus 2 equals 0. So here we're going to get the tan of x is equal to 3, and here the tan of x is equal to negative 2. Okay, we don't know exact values for tan of x equals 3 or tan of x is equal to negative 2. So this is a calculator question. Okay, you can use your calculator in this example. I just wanted to let you know a couple things for sine and for cos. The range of this function, in other words, the largest value you can have. If you plug in a theta, the largest that sine theta can be and the smallest that sine theta can be is from -1 to +1. So if I go -1 is less than or equal to all the possibilities of what comes out of sine theta and +1. Okay, or if you wanted to use interval notation, it would be -1, comma 1, and then the square brackets like that. Okay, same thing for cos, right? This is also true for cos. So it's from -1 to +1. Now tan, however, tan can be anything. So tan can be from -infinity up to +infinity. You can put it that way, or you can say all real values. Okay, so you can get anything. So you might say, like, if you had the sine of x was equal to 3, there's no solution. Like if you plug that into your calculator and say, you know, like this. This is saying, so what value of x can I plug into sine so that a 3 comes out? Well, you're never going to get anything bigger than a +1 or smaller than a -1. So if you look at our unit circle, right, this is this is +1 up here and this is -1 up here. It's all either between -1 and +1 on the y-axis, and same as the x-axis for cos. You're never going to get anything larger. But for tan, because tan is equal to the y over the x, if you have your x really small, like if you pick a point over here, you know, your tan is equal to y over x, you can have, say, 0.9 over some very small x value, 0.00001, if you get really close there, and you'll get some large number. So you can actually get, tan can be all real values. So plug it into your calculator, and the x here will be equal to the inverse tan of 3. I will just cheat by looking at my own calculator instead of punching it all in, and I think when you do that you get a value of 71.6 degrees. Okay, and if I plug in tan of x is equal to -2, if I plug x is equal to the inverse tan of -2, I think that I get an answer of -63.4 degrees. Okay, so what does this mean, and what can we do to finish the question? I'm trying to erase here. Normally, we can say that you'd use the unit circle and all that kind of stuff, but for tan, the thing to remember is that the period of tan, the amount that it repeats, how often it repeats, is not 2 pi like sine and cos. Okay, so sine and cos, both of these ones, they repeat, every 360 degrees or 2 pi. Okay. In other words, for another way of saying repeat is what's its period? How often is it? So remember, if we had a given degree here in sine and cos, we could say, well, the next time we're going to get that would be 360, right? A coterminal angle would be at 360. For tan, however, tan repeats every 180 degrees or pi. So why is that? Well, it has to do with the fact that we got plus plus here and negative here. So if this is your reference angle for tan, 180 degrees later, that one is also going to work, right? So if I've got 71.6 degrees, I can add or take away multiples not of 360 but of 180, and I want to be within 180 and 360, so I would have to right away add 180 to that, and I would get, what is it, 251.6, and this one is out of my interval, my required domain. This one works. For negative 63.4, I would have to add 180, and I would get 116.6 degrees. Still not within that interval, so I'm going to add 180 again, and my next one would be 296.6 degrees. So that would be, these would be my two answers for the tan of x, for x. In the background there is friendly Mr. Wagner making some type of an announcement. We're getting through it, aren't we? We only got 2 questions left. I know it's a bit of a long video. There's a lot of stuff here, so if you need to go to the bathroom and take a break and come back, I'm all good for that. It's no problem. But I'm right here. So this question here again is a quadratic one that we can factor. So if you want, we can go let a equals sine of x again. And then we can say a squared plus a minus 12 equals 0. So we need two numbers that multiply out to negative 12 and add up to plus 1. So how about plus 4 and minus 3 equals 0. So then I'll bring it back to the sign again. So then I've got sine of x plus 4 multiplied by the sine of x minus 3 equals 0. So I want to find out, the possibility is sine of x is equal to negative 4. The sine of x is equal to 3. Now it's just like what I was talking about before. This value can only be between negative 1 and positive 1. This value can only be between negative 1 and positive 1. So in this case you'd say no solution. Okay, or another way to write it is you could say that is another way of saying no solution, because it has to be within negative 1 and positive 1. If you try typing in your calculator and you'd say, okay, well, x is equal to the inverse sine of negative 4, it's going to say error. Or if you say, similarly, if you say the inverse sine of 3, you're not going to get anything, so it's not going to work. So that was quick, and now we only have letter h to go. So we have cosecant squared plus cosecant x minus 12 is equal to 0. So if we factor this out, we'll get cosecant x, and we want two numbers that multiply out to negative 12 and add up to positive 1. So it's really the same as before, so we'll get plus 4 and minus 3 is equal to 0. And now we want between 0 and 2 pi. So here we can say the cosecant of x is equal to negative 4. So x, now this is a reciprocal function. So the reciprocal of cosecant is sine. So we can say the sine of x is equal to negative 1/4. And here cosecant of x is equal to 3. So the sine of x is equal to 1/3. I'm just going to pause quickly so that I can get my calculator out and figure. Alright, so I just paused and did my calculator work, and I came back rather than doing the calculator sort of like on screen. So my sine of x is equal to negative 1/4. So what does that mean? That means that whatever my angle is, my y value because it's sine, the y value is equal to -1/4. So it's going to be somewhere over here. But what I'm going to do is say then the sine of my reference angle, which would be in the first quadrant, is equal to +1/4. Okay, so my reference angle is going to be equal to the inverse sine of 1/4. And when I type that in, and remember I'm in radians, when I'm in radians, then I'm going to get an answer of 0.2527 from my calculator. Now, does that make sense? So if my y value is a quarter, so a quarter is quite small, then my answer is 0.2527 radians. Well, if I go all the way over here, that's pi radians, that's 3.14. Up to here is half of a pi, so it's 1.57. So I just want to go just a tiny little bit, 0.2527. So that's this amount of rotation. That's my x value, 0.2527. Now, when is sine negative? So sine is negative in quadrants 3 and 4. So in quadrant number 3, you know what, I'll leave some space for this. Maybe I'll work over here. So if I've got my xr is equal to 0.2527 in quadrant number 3, I want to say pi plus x is going to be equal to pi plus my reference angle. So using the pi button on my calculator, instead of just 3.14, I type that out and I get 3.3943. You'll notice that it's good to go all the way to 4 decimals for radians in decimal form. And my next one would be in quadrant number 4, it's going to be the full circle 2 pi minus. So in quadrant number 4, it's my answer is going to be 2 pi minus my reference angle. So it would be 6.0305. Okay, so I've covered this cosecant x plus 4 factor. Now I need to do the other one. Maybe it'd be a good idea if I switch to green so that you can see what's going on. It's a little bit easier because it's not a negative value, it's a positive value. So here the sine of x is equal to 1/3. In other words, my y value is 1/3. All the way up would be 1, so 1/3 would be like this. So again, it's a fairly small angle, but it's a little bit larger. And I'm going to get a value in quadrant number 1. When I just type it in my calculator, that's what I'm going to get. And I'll also want something in quadrant number 2 as well. So when I type it in my calculator and I say x is equal to the inverse sine of 1/3, and again making sure that I'm in radians, the answer that I get is 0.3398. And then that's my first quadrant answer. In the second quadrant, it's going to be equal to pi minus my reference angle. So that would be 3.1428 minus that 0.3398. So that answer is 2.8018. Okay, so making a little bit of a mess here at the very end. So here are all my answers, and I'll summarize, and I'll say x is equal to, and maybe I'll start from my smallest and go ascending, so it's 0.3398, and then my next one would be 2.80018, comma 3.3943, comma 6.0305. And those are my 4 answers. So a little bit of work for that last one. And I'm not sure if there's some homework assigned for this one or not, but I'll get to you in class to make sure that you can do some practice on these.